Hey guys, what's up? It's me, Leaf. Today we're going to be talking about blockchain development. And one of the most important things in blockchains is the token system. We have a standardized token system called ERC20, and that's going to be what we're building today. So in this video, for the sake of time, I didn't want to make it an hour-long video, so we're not going to be going into what blockchain is, how the Ethereum network works, or anything like that. Today we're just going to be coding a ERC20 standardized token and then deploying it to our local blockchain. Luckily for you, if you don't understand these things fully, you don't need to know that in order to code along with me today, but you should probably understand those things at some point in your life if you want to get into blockchain development. And one more side note, I'm not currently monetized on YouTube and I don't have any sponsorships, so I'm doing this video completely for free. It would really mean a lot to me if you could hit the like button on this video if you enjoyed it, and also leave a comment because that helps out the YouTube algorithm. Thank you. Let's get into the video. The first thing we're going to do to set up our developer environment is we're going to get Node.js. Most people already have Node.js, but if you don't, just download the most current version. It should work fine. The next thing we need is two applications involving with the Truffle suite. So the first thing we're going to do is we're going to install Truffle. So you can go to the Truffle website and then find this link here, or you can just go to your terminal and then type in npm install truffle-g, and that will globally install Truffle framework onto your machine, and you will not need to do anything else. You can just do Truffle version to verify that you have it, but that should be installed. The last thing we're going to need is Ganache, and this is also made by Truffle. So just download Ganache from the Truffle website, and you will have it installed. It's an application, and we will use that later on. All right, now it's time we open up your IDE of choice and then open up a new project folder and then go to the terminal and type in truffle init. This will create a new Truffle project and it will contain contracts, migrations, a test. We won't use that today. And they'll also have the truffle config.js. Go to the truffle config.js and we're going to tell it which compiler version to use. So let's switch to 0.8.0 so we can use use a more modern version of Solidity. So Solidity is a programming language that we write smart contracts for the blockchain in. And we will be using that right now, actually. We'll create a new Solidity file under contracts, and we'll call this token.sol. This is a Solidity file, so the first thing we need to do is we need to tell it which compiler version to run. In this case, we're going to do 0.8.0, and the way we do that is pragma Solidity. We use the up caret sign, and then 0.8.0. Great. The next thing we're going to do is we're going to import a package called openzeppelin, which has a ERC20 standard. It's a token standard for blockchain tokens. And in order to get this into our project, we're going to have to go to our terminal, npm install, and it's going to be openzeppelin / contracts, I believe. And once we run this, we will have it in our node package, our node modules folder. And we can see that here, node modules, openzeppelin, under token, erc20.sol. And that is the file that is going to contain pretty much everything we need in order to make our tokens. So this is already made for us. We don't even need to really focus on working that. We just need to customize it a little bit. So now we're going to actually create the smart contract with this syntax here. It looks similar to creating a class in Java maybe. And then is ERC20 means that we inherit from the ERC20 smart contract in the ERC20.sol file. Now we're going to declare a address. It's going to be public, and then we're going to make it called minter. This is a variable. It's going to hold this variable here. It's going to be whoever creates this contract is going to be set to minter. That's going to be the message.sender namespace type deal is going to be set to whoever initializes this contract, whoever calls this constructor. And then we're going to have this is how you make another constructor, or call another constructor of a class that you're inheriting from, or a contract you're inheriting from. ERC20, we're going to pass it the name and then the ticker symbol for it. Great. And it's going to be payable as well, but you can ignore that. That's fairly complex. So now we're going to create this function called mint, and this is going to be what we do to call our own, to mint our own tokens, basically to create our own tokens and send them to an account. So we take an address of account that we're going to send it to, and then we take a uint of the amount. And the reason we are creating our own function, this actually function does exist in the ERC20 package, but we want to require that the message.sender, the person of this function, is equivalent to the person who created the contract. We don't want anybody to just be able to mint these tokens. So now that we've required that, if this evaluates to false and they are not the original contract creator, then this will just return the function and no gas will be paid or anything. So this mint function here is the one that is a part of ERC20, and we'll call that with the account and the amount, and that will mint our new tokens. Great. So that looks good for our purposes today, and this is definitely a very simple version of this token, but it works. So now we go to migrations, and this is all written in JavaScript. So let's create a new file, and as per naming convention, we will call it to underscore whatever we want. I'm just going to call it deploy contract and .js, of course. And here we will do this line of code. And this line of code turns our Solidity token into a JavaScript object, and we call it token. So that's what artifacts.require token does. Now we'll do module.exports equals this is going to be an async function, and we pass it deployer, and then we await deployer.deploy, and then send that our JavaScript version of our Solidity file, our Solidity smart contract, and that will deploy this to the blockchain when we run this. So we can save this file, and if you're interested more in how this all works, then go read the Solidity documentation. And if you don't really care, then just continue on. Truffle compile will compile our project. And let's see if it works. And it does work. Great. Everything's working well. So now we need to open up Ganache in order to create our local blockchain. So let's open up Ganache real quick. I'm just opening it right now. And we'll click Quick Start. Quick Start. And that'll be an Ethereum network. And it will give us some fake ether to use with some fake accounts in a local blockchain. Great, so we can see all these addresses and stuff going on. Now, since Truffle and Ganache is integrated with one another, we don't have to do anything further. This will just work magically, I guess. And we will say Truffle Migrate, and this command will migrate our migrate to the blockchain. So you can see that it costs gas. The final cost is 0.0325 ether, which is, if you follow the ether market right now, which is a lot of money. It's like $70 some at the current time of me making this video. And yeah, so it is quite expensive to deploy these contracts. So it's a good thing we have a test network. Let's use Truffle console to open up a JavaScript console to interact with the blockchain. The first thing we're going to do is we are going to set this token variable equal to await token.deployed, and this will make it so we can use this variable to interact with our contract. Token, let's do .symbol, and this will return the ticker symbol. Token.name will return the name of the token, and token.minter will return the person who is the minter for these tokens, the person who deployed this contract, which was the first address in our blockchain. Now let's create an array of accounts in the blockchain. So accounts equal, we're going to do await web3.eth.get accounts, and this will return an array of accounts, all the accounts of the blockchain. We can view that by just printing it here. So we can see that we have all these addresses, these accounts. So we're going to set one of them equal to an account. Let's do the second index in the array here. So that'll be account 1. This will be the second index, and I guess I'm kind of making them out of order, but I'll set this the first one in the array as well equal to account 0 with accounts.0. So now we have 2 accounts to play around with. And now let's token. Let's call our original function here. We have token dot mint, and then we're going to send it an account and an amount, and that is going to mint some new tokens of amount to the account. And this amount is not going to be equal to our regular 10 ether or 10 of my new token. It's actually in a form called Wei, which is a smaller broken up version of any sort of token. And we have a nice util function that will return the amount of Wei if we just pass it a string of an amount. So say we want 50 of our new tokens, it'll convert it to Wei for us. Great. So now we have this transaction went through, and we got a little receipt for it, which is nice. So we know that this all went through. Now we can switch this up. I made a mistake here, so I'm just gonna I just gave 50 to account 0. That was what I did here. So now we have 100 total tokens in our system, 50 on account 0 and 50 on account 1. So we can run, we can make total supply equal to token.totalSupply. We'll have to do the await keyword, of course. And then we can do total.toString and view how many tokens are in the thing. And again, this is in Wei, so we can convert this from Wei to our total from Wei, and we will receive this. Great. So now we have our 100 tokens that are in supply. So let us view the balances of our accounts. So account 0 balance equals await token dot get balance. Balance of, I think I mistyped the function here. It's not get balance. This will return an error. We're going to do, it'll correct itself in a second. It's going to be balance of is the name of the function. Await token dot balance of account 0, and then account 0 balance to string will be equivalent to 50 tokens. Yeah, of course, this is written in a way, so we could convert that if we want, but you guys get the point. So now we're just going to open up Ganache and view that in fact our ether was consumed to deploy this blockchain. And that's pretty much everything for this tutorial. Alright, so that does it for this video. Thank you guys for watching all the way till the end. Really appreciate it. If you did enjoy blockchain content like this, please consider subscribing to my channel. I'm going to be doing a lot more of that in the future. And also, if you could leave a like and comment on the video, that would be greatly appreciated. Thank you guys so much. Have a good day.